All right, so I know absolute value inequalities, these are covered probably more briefly in Algebra 1. They're not stressed a lot in Algebra 1, but rather they're introduced in Algebra 1. So by the end of this lesson, you want to be able to solve an absolute value inequality. And I do have, for the first part, I have two examples that explain, or I'm going to use to explain, why the solution set for an absolute value inequality is what it is. So if we look at example 1, part A, we're going to solve the inequality, graph the solution set. And actually, we're going to use the graph to get the solution. But looking at this, absolute value of x is less than 3. I want to talk about what this means. So how did we say absolute value is defined? What does absolute value mean? Distance from 0. So this means that the distance x is from 0 is less than 3. Is what that absolute value inequality is stating. X is some number that has a distance that is less than 3 away from 0. So I'm going to think about on a number line, I'll just put 0 on there, what values x could be. So what are some values that would fit in this solution set for x? Values that have a distance from 0 that's less than 3. 2. Claudia? 1. You can just shout them out too. Any others? -1. -2. What about, and obviously any, if there's decimals, things like that. What about 3 and -3? I see some no's. It's just less than, not less than, or equal to. So if it was or equal to 3 and -3 would also work. So if we were to shade in on this number line the values that x could be, so the solutions, we would have circles, open circles on 3 and -3 because they're not included, but any number in between -3 and +3 is a solution. All of those numbers have distances from 0 that is less than 3. Now hopefully from yesterday, the graph of this inequality looks familiar because this is the graph of a compound inequality that we reviewed yesterday. So would this be the graph of a compound inequality that would be joined by and or by or? I heard both. And. So and is where the shading is where both of them would overlap. So compound inequalities involving and, their graphs usually are two endpoints shaded in between. So this would be a compound inequality involving and. So if we were to write this solution set, so this is the graph, the solution set would be that x can be any number that would be greater than -3, and x could also be, and x would have to be less than +3. So all of these values that are shaded are greater than -3 and less than +3. But the main idea I want you to see here is that an absolute value inequality, its solution is a compound inequality, which is what we reviewed yesterday. And then because this is a compound inequality involving and, we can write this in the more combined way to show that x is in between negative and +3, so we could also write it in this form. You wouldn't have to write it in both. And again, you can get to that form if I were to flip that first inequality around and put those inequalities together, it would be in that form. So this is the solution set. And that's our big idea. The solution set for an absolute value inequality is going to be a compound inequality. So then if we look at example B, absolute value of x is greater than 5. So the distance a number x is from 0 is greater than 5. If I think about this on a number line, again, I'm just going to stick 0 on there. What values could x be? You can just shout them out, too. 6. 6 would work. I heard some other mumbles. I just didn't hear what the values were. Any others? Does 5 work? No. Does 4 work? No. So that's going the wrong direction. I'm still going to put 5 on there, but 7 would work. What about negatives? Negative 6 would work. Negative 7 would work. Negative 5 doesn't. I'm just still going to put it on the number line, and then negative 4 would not. So what this graph would look like is I would have an open circle at negative 5 and at positive 5. They're not included. If it was or equal to, I could put dots there. But I'm shading values that are less than negative 5, or to the left of negative 5, and then to the right, or greater than positive 5. So this would be the graph still of a compound inequality, but now it's a compound inequality joined by or, because the shading is in opposite directions. The shading does not overlap. So writing the solution set, it would be x values less than negative 5, or x values greater than positive 5. And remember, if it's joined by or, we cannot write it in this combined way. This is the solution set. It's not in set builder notation or anything like that, but that is the solution set. All right, so looking, I'm going to reference these examples, but looking below here, it says at the top, above that box, an absolute value inequality can be solved by first rewriting it as a compound inequality. So when you see an example, like if you looked at example 2, you have an absolute value inequality. Your goal is to first write it as a compound inequality, and you need to know, is it joined by and or is it joined by or? And then how do I set up the two inequalities? And that's what this box is referencing, and I'm going to help explain why this is set up the way it is using these examples. So if we look at this box, so first of all, if you have an absolute value inequality in this form where you have a greater than or equal to symbol, if it's greater than, it's going to be a compound inequality joined by or. And then if it's less than, I know this is written in the combined way, but it's a compound inequality joined by and. So if you haven't heard this before, this is a way I remember it. When I see a greater than symbol, I think great or, to remember that it's an or, great or, and then a less than symbol, less than, to remember that it is and. So great or, less than, to remember which is which. It does make a difference. Whatever word you stick in the middle of those two inequalities makes a difference in your solution set. So yes, it matters what word is written there. And then how the inequalities are set up is, so for the first one, notice what is inside the absolute value bars, the ax plus b, that's not going to change. So the first inequality is keeping the ax plus b. You keep the greater than symbol, if I'm looking at the very first box here, keep the inequality the same, and then keep the value on the right side the same. So it's basically, if you think of absolute value equations, where we set up a positive case and a negative case and then solved both, that's kind of what this is. Your positive case means you're not changing anything about the inequality. Your negative case, though, not only are you going to make the C negative or change it to the opposite, but you also have to switch the inequality sign. So the sign switches, and the right side of your inequality changes to the opposite, or if you want to say it turns negative, but changes to the opposite for the negative case. And then it gives an example there, but we'll go through examples together as well. And then for the formula they have down here for the and case, so if it's less than or equal to, it's an and. This is one way you can write it, and this is showing that whatever is in the absolute value bars is going to be in between positive C and negative C. But you can also write it as two separate inequalities joined by and, the exact way this one is set up with or. So the first inequality would be keeping everything the same. You're just dropping the absolute value bars. Your positive case. So ax plus b, keep the less than symbol, keep the c. And then you would join it with and your second inequality would keep the ax plus b. You would switch the less than to be greater than, and then change c to the opposite, so negative c. So it'd be set up the same way it is for the or, except you have and in between, and yes, then your solution set is going to look different based on the word that's in the middle. So in example 2, we're just going to go through a couple examples together, but the steps I would work through with this is when you see an absolute value inequality, just knowing that you have to rewrite it as a compound inequality, so 2 inequalities, and figure out what word is joining them. So I usually figure out what word is joining them first. Is it an or is it an and? So for example 2, I have a greater than or equal to symbol, so great or, so this is going to be joined with or. And then I set up my compound inequality joined by or. So my first inequality, positive case, again, everything stays the same. I just drop the absolute value bars. So 6y minus 5, keep the greater than or equal to symbol, keep the positive 13. And then I have or, my second inequality, I keep the 6y minus 5. I switch the inequality to less than or equal to, and I switch the 13 to negative 13. So the negative case, not only the right side becomes negative, the sign switches. Now I just have to solve this, and that's what we worked on yesterday. So now you just have the one extra step of rewriting it first, and then you're solving a compound inequality. So for an or, I have to solve these both separately and then put them together as my solution set. So solving the first inequality, I would add 5 to each side to solve for y. So 6y is greater than or equal to 13 plus 5 is 18. And then divide each side by 6. So y is greater than or equal to 3. And then I can bring down the or. The second inequality, I'm going to use the same steps to solve for y. I'm still adding 5 and dividing by 6. I'll just have a different answer. So add 5 to each side. So 6y is less than or equal to negative 13 plus 5 is negative 8. And then divide each side by 6. Now negative 8 divided by 6 is a repeating decimal, so leave it as a fraction, but make sure it's simplified. So that would be negative 4 thirds. So y is less than or equal to negative 4 thirds. And when you have a compound inequality joined with or, you have to leave it written this way. 2 separate inequalities joined by or. Do not circle each of these and say these are my 2 answers. It's not 2 separate answers, it's together, joined by or. And then for set builder notation, in front of this I can just include the brace, define the variable y, vertical line for such that, and then close off the braces. So this would be the set builder notation. The only way you could write it differently is if you switched the 2 inequalities. So you wrote the y is less than or equal to negative 4 thirds first. That would be fine. Any questions on solving it, setting it up, or solving it? Kim? Feel free to go. Good luck. If you need to see the rest of it, I'm recording it. I'll put it on Canvas and then the assignments on the bottom. Okay, so then for the graph, on the test, as I said before, I will give you, like the number lines will already be labeled. That's for my ease in grading it. Everybody's number lines are labeled the same, so I know what I'm looking for each of them. So if this were, just because this is a fraction, I just want to show you, if this was set up as a number line I were to give you, you wouldn't see fractions on your number line. So let's say here's 3, 2, 1, 0, negative 1, negative 2. So if this was the number line you were given, to graph this solution set, I would graph each inequality on the same number line. So if I'm graphing y is greater than or equal to 3, I would have a dot on 3 shaded to the right, everything greater than that, and then y is less than or equal to negative 4/3. So this is negative 1 1/3. So about where negative 1 1/3 would be, I would put a dot. If you were making your own number line and you just put negative 4/3 and 3 on there, that's fine, but on the test you wouldn't see that. So this would then be shaded to the left. So if it is a fraction or a decimal, you would just put the circle or the dot where that decimal or fraction would fall on the number line. And then I'm going to review the interval notation with you as well. So here we have 2 parts to our solution set. So we are going to have 2 intervals joined by the union symbol. So this first part of the number line is being shaded all the way down towards negative infinity. So that interval is negative infinity up to negative 4/3. Negative infinity always has a parenthesis. Yeah, negative 4/3 is going to have the bracket. It's included. It's a dot. It is a solution. Join them with the union symbol. And then the next interval starts at 3 and extends up to positive infinity. So 3 to positive infinity. The 3 is included, so it gets a bracket. Infinity gets a parenthesis. So this would be interval notation for example 2. And how that's going to look on the test, I just had a couple questions in my other 2 classes. So when you see a problem, say I give you an inequality, I ask you to solve it and to graph the solution set. So the number line will already be there as a reminder that you need to graph. I'm only going to ask you for your answer in one of the 2 forms. So it's not like you're doing both. I will clarify in the directions what form your answer should be in. But it's either going to be set builder or interval notation. So you do need to know both. Okay, other questions before we move on to example 3? Okay. So example 3, absolute value of 5z plus 2 is less than or equal to 17. So looking at this inequality before we rewrite it, will it be a compound inequality joined with and or with or? And less than. Now, if it's an and, there's 2 ways you can set it up. I do not care which way you set it up. Use whichever method makes the most sense to you. So I'll show you both. The first way to set it up is to set it up exactly the same way you set up example 2. It's just and in between. So if I'm writing 2 separate inequalities, I would have the first one is keeping everything the same. So 5z plus 2, keep the less than or equal to, keep the positive 17. Then we have and. The second inequality, keep the 5z plus 2, change the inequality to greater than or equal to, and the 17 becomes a negative 17. And then you solve both of these inequalities, write your solution set, make your graph, and you'll have your answer. So that's one way to set it up. The other way is to use that condensed form. So I'll write it and then I'll explain how these 2 are really the same. So this would look like negative 17 is less than or equal to 5z plus 2 is less than or equal to positive 17. So basically how to write it in this form is you take what's in the absolute value bars, and that's in the middle, and then whatever value is on the right of your absolute value inequality, that middle expression is always in between the positive and the negative of that number. So I'll show you this. If I cover this one up, here's the 5z plus 2 is less than or equal to 17, that first inequality over here. If I cover this part up, this is the exact reverse of how we wrote it here. So if we had switched this whole thing around, this is what we would see. So both inequalities are there in that form. If this form confuses you, don't use it. That's all I'll say. So if this form, if writing it this way confuses you, write it the first way. And then if we solve this, just to review from yesterday how this solution set looks, I'm going to solve it using the second method where it's combined. So in this method, I need to get the variable by itself in the middle. So I would first need to subtract 2, and that means I also subtract 2 from both sides. So it cancels out in the middle. On the left, I'm going to have negative 19 is less than or equal to 5z is less than or equal to 15. And then divide by 5 and divide both sides by 5. Now on the left, I can keep negative 19/5. It is a simplified fraction, or I can write that as a decimal since it does terminate. It's negative 3.8 is less than or equal to z is less than or equal to 15 divided by 5 is 3. And that is your solution set, so I can just add in the set builder notation around it. So if you solved it separately, I'll just show this in case any of you solved it the first way. Your first inequality would come out to be z is less than or equal to 3, and the second one would come out to be z is greater than or equal to negative 3.8. So yours would be written this way, means the same thing. And then to graph this, so here I'm just going to put the decimal on the number line. So I have negative 3.8, and then I have positive 3. Based on the inequality symbols, they both have dots. And the combined form shows that z is in between those values, so you're shading only in between. So don't look at that combined method and think that it's extended all the way to the left. It doesn't go past negative 3.8 in this case. It's just in between. Z is in between the two numbers. And then the last thing, interval notation. So because we're not extending in either direction towards negative or positive infinity, these are the two endpoints we have. So it extends from negative 3.8 up to 3, and they're both dots on the graph. They're included, so they're both brackets. So it's just one interval. And notice you just have one segment on your number line shaded, so that's why there's only one interval. Questions on that one?